This is Spacetime Series 27, Episode 63, for broadcast on the 24th of May, 2024. Coming up on Spacetime, some of the universe's oldest stars found in our own celestial backyard, Europe's JUICE spacecraft now a year into its 8-year journey to Jupiter, and Russia test launches its new heavy-lift Angara A5 rocket. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have discovered 3 of the oldest stars in the universe in the halo of our own Milky Way galaxy. The galactic halo is a cloud of stars that envelops the entire main galactic disk. The new findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, suggest that these 3 newly discovered stars formed somewhere between 12 and 13 billion years ago. Now, that's a time when some of the very first galaxies were only starting to take shape. The researchers have coined the stars SAS, which stands for Small Accreted Stellar System stars. That's because they believe each star once belonged to its own small primitive galaxy that was later absorbed by the larger but still growing Milky Way. Today, it seems these 3 stars are all that's left of their respective galaxies. The study's lead author, Anna Friebel, says there are likely to be lots of similar ancient stars in the galactic halo, given what astronomers already know about galaxy formation. As they uncover similar SAS stars, the authors hope to use them as analogues of ultra-faint dwarf galaxies, which are thought to be some of the universe's surviving first galaxies. Such galaxies are still intact today, but they're too distant and too faint for astronomers to study them in depth. So, as SAS stars may have once belonged to similarly primitive dwarf galaxies, but are in the Milky Way and therefore much closer, there could be an accessible key to understanding the evolution of ultra-faint dwarf galaxies. Friebel says the team can now go looking for more analogues in the Milky Way, where they're much brighter and easier to find and study their chemical evolution, without having to chase these extremely faint stars. The group collected star data collected by Friebel using the 6.5-metre Magellan Clade telescope at the Los Campos Observatory in Chile. They were searching for ancient stars that would have formed soon after the Big Bang 13.8 billion years ago. Now, during this time, the universe was made mostly of hydrogen and helium, and very low abundances of other chemical elements, such as strontium and barium. So the team looked through Friebel's catalogue of stars with spectra, that is, measurements of light coming from stars that provide clues about the chemical composition. And they were especially looking for low abundances of strontium and barium. Eventually their search narrowed down to 3 stars, originally observed by Magellan in 2013 and 14. Now, it seems the original observations were never followed up to interpret their spectra and deduce their origins. So the authors undertook the work, finding that these 3 target stars had very low abundances of strontium and barium, as well as other elements such as iron, when compared to a reference star, in this case the Sun. In fact, one star contained less than 1/10,000th the amount of iron to helium compared to the Sun today. Now, the low chemical abundance in these stars indicated that their ages are likely to be between 12 and 13 billion years old. In fact, their low chemical signatures were similar to what astronomers had previously measured in some ancient ultra-faint dwarf galaxies. So the authors then checked the stars' proper motion across the sky, that is, their orbital trajectories. The 3 stars are each in different locations in the galactic halo, and each are estimated to be about 30,000 light-years from Earth. Overall, the Milky Way's disk spans some 100,000 light-years in diameter, and we're roughly 27,000 light-years from the galactic centre. So these stars are a long way out. Now, as they traced each star's path around the galactic centre using observations from the European Space Agency's Gaia satellite, they noticed that all 3 stars seem to be going in the wrong way, that is, in retrograde motion, compared to most of the other stars in the Milky Way. And that suggests that each of them must have originated in another galaxy which was cannibalised by the Milky Way billions of years ago. The authors have now found some 65 additional stars also with low strontium and barium abundances. And they also appear to be orbiting in retrograde, suggesting once again that they're all ancient and belong to other smaller dwarf galaxies that fell into the Milky Way at random angles, with the stars continuing on strange trajectories billions of years later. This is Space Time. Still to come, the European Space Agency's JUICE spacecraft, now a year into its 8-year journey to Jupiter. And the Kremlin undertakes a successful test launch of Russia's new heavy-lift Angara A5 rocket. All that and more still to come on Space Time. The Jupiter Icy Moons Explorer, or JUICE spacecraft, has just celebrated its first year in space as it continues its epic 8-year journey to the Jovian ice moons Ganymede, Callisto and Europa. Launched aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana back on April the 14th last year, the interplanetary probe is targeting the 3 Galilean moons because they're all thought to have significant bodies of liquid water beneath their frozen surfaces. And that makes them each a potential habitable environment for extraterrestrial life. JUICE is the only interplanetary spacecraft to the outer solar system's planets not launched by the United States, and it will be the first to orbit a set of moons other than Earth's. There are 4 gravity assists planned by JUICE in order to place it on a trajectory to reach Jupiter. Firstly, there will be a flyby of the Earth-Moon system in August this year. That'll be followed by a slingshot around Venus in August next year, a second flyby of the Earth in September 2026, and a third and final flyby of the Earth in January 2029. JUICE will pass through the asteroid belt twice on its way to the Jovian system. A flyby of the asteroid 223 Rosa was proposed to occur in October 2029, but it was abandoned to save fuel for the primary mission. Finally, in April 2031, JUICE will fly by Jupiter's moon Callisto, offering scientists a tantalizing glimpse at this mysterious cratered alien world. It's expected to achieve Jovian orbit insertion in July, and in December 2034, the spacecraft will finally enter orbit around Ganymede for its close-up science mission. JUICE will perform a detailed investigation of Ganymede and evaluate its potential to support life. The mission will characterize the giant moon's subsurface ocean and water reserves. It will undertake a topographical, geological and compositional mapping survey of its surface, including the physical properties of its icy crust. JUICE will also characterize Ganymede's internal mass distribution, its dynamics and evolution of its interiors. It'll study the moon's tenuous atmosphere, as well as its intrinsic magnetic field and the field's interaction with the Jovian magnetosphere. Investigations of Europa and Callisto will complete a comparative picture of these 3 Galilean moons. For Europa, the focus will be on the chemistry essential for life, including organic molecules, and on understanding the formation of surface features and the composition of the non-water ice material. JUICE will also provide the first subsurface sounding of the moon, including the first determination of the minimal thickness of the icy crust over the most recently cryovolcanically active regions. More distant spatially resolved observations will also be carried out for several minor irregular satellites, as well as the volcanically active moon of Io. This report from ESA TV.
The giant planet Jupiter is a place of intrigue and mystery, a special environment within our own solar system. When Galileo first raised his telescope to the planet, he discovered 4 moons: Io, Europa, Ganymede and Callisto. Early space probes raised more questions than answers about this fascinating gas giant planet and its intriguing moons. Now, those answers are within our grasp. The Jupiter Icy Moons Explorer, JUICE. JUICE is equipped with the most powerful science payload ever sent to the outer solar system. 10 instruments will conduct the most comprehensive remote sensing, geophysical, and in situ measurements ever performed at Jupiter. To bring JUICE to life, ESA has led a consortium of more than 2,000 people in 23 countries, working in 18 institutions and 83 companies. NASA, the Japan Aerospace Exploration Agency, and the Israel Space Agency have all supplied hardware. For 8 years, JUICE will cruise through space before beginning a complex series of manoeuvres in the Jupiter system. During this time, JUICE will face many dangers. Radiation near Jupiter can fry the spacecraft's electronic brain. The planet's gravitational pull is so large, it could threaten derailment, Nevertheless, ESA's expert spacecraft operators will guide JUICE through 35 flybys of Europa, Ganymede, and Callisto before orbiting Ganymede. But the dangers will be worth it for the science that JUICE will uncover. Europa and Ganymede are thought to contain subsurface oceans that could hold more water than Earth's oceans. JUICE will explore these moons to study whether life could arise in different environments across the cosmos. JUICE will also study Jupiter's complex weather, chemistry, and climate in detail. It will turn Jupiter into a standard reference for us to compare against other gas giant planets throughout the cosmos.
This Space Time. Still to come, Russia tests their new heavy lift Angara rocket, and later in the science report, a new study shows that junk food has been linked to a higher risk of over 30 different physical, mental health and sleep problems. All that and more still to come on Space Time. The Kremlin have undertaken a successful test launch of Russia's new heavy-lift Angara A5 rocket. The flagship A5 is a more powerful version of the Angara family of rockets. They've been developed to replace the old Soviet-designed Proton rockets, which, together with the even older Soyuz rockets, have been the workhorses of the Russian space program for decades. The three-stage Angara A5 is designed to carry up to 24.5 tons into LEO or low Earth orbit and 5.4 tons into geostationary transfer orbit. The test flight was carried out from Moscow's Vostochny Cosmodrome in Russia's Far East. Two earlier launch attempts during the week were scrubbed. Yuri Borisov, head of the Russian Federal Space Agency Roscosmos, says the first attempt to launch was cancelled just 2 minutes before liftoff due to the failure of a pressurization system for the oxidizer tank in the central block of the rocket. He says a second launch attempt the next day was aborted by the automatic safety system, which registered a flaw in the engine start control mechanism. This test flight was only the fourth flight of the Angara A5 in 10 years. The program has been beset with technical issues, funding problems, and quality control concerns. The previous test flight was only deemed partially successful when the upper stage failed to restart for a second engine burn. All of the three previous test launches were carried out from the Plesetsk Cosmodrome north of Moscow. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that up to 246 million older adults around the world are projected to be exposed to dangerous acute heat by the year 2050, with those living in Asia and Africa experiencing the most severe effects. The findings, reported in the journal Nature Communications, claims that by 2050, more than 23% of the global population aged over 69 will live in climates with acute heat exposure greater than the critical threshold of 37.5 degrees Celsius, compared with the 14% in 2020. The authors suggest that areas with aging populations and rising heat exposures are likely to face considerable demands for social health services, and policies will need to be developed to accommodate this. Scientists have found that eating more junk food, such as packaged snacks, sodas, and sugary cereals, is associated with a higher risk of more than 30 different physical, mental health, and sleep problems. The findings, reported in the British Medical Journal, combine the results of 45 previous meta-analysis studies. The study's authors say that while this kind of research can't prove that junk food is causing health problems, there was consistent evidence that ultra-processed foods are associated with death and specific conditions, including type 2 diabetes, obesity, anxiety, sleep problems, and wheezing. When it comes to believing in playground gossip, it seems even young kids rely on multiple sources to verify the gossip. The findings, reported in the Journal of the Royal Society Open Science, looked at 107-year-olds who were told either positive, neutral, or negative gossip from a group of puppets before allocating sticker rewards to the subject of the gossip. It took positive gossip from multiple informants to impact their choice of reward. but the kids would act straight away on negative gossip, whether it came from one or multiple sources, although they were more likely to trust negative gossip that came from more than one source. The authors say the study shows that kids are sensitive to objective indicators, such as the number of gossip sources, when determining a piece of gossip's credibility. There's been another Bigfoot sighting, this one in the city of Manchester, England. Tim Mendham from Australian Skeptics says this one was actually more of a Bigfoot feeling than an actual sighting.
Bigfoot, Sasquatch, Yeti, Yowie, whatever you like to call it, appears supposedly all around the world. There's a lot of countries which claim to have tall, hairy men. So, latest thing, a fisherman in the UK near Manchester, by a stream at night by himself, sounds a bit creepy, had a feeling of being watched. Therefore, he didn't actually see anything. But he thought there was something there. So that becomes proof of Bigfoot in the UK. This fellow was also he had reported other paranormal events in the past. So
well, of course he had.
It's a bit prone to this. So this became a bit of an interesting story. The pro-Bigfooters naturally took it up and said, see, this is proof. And others keep showing photos, and they're always terrible photos of some shape behind a lot of trees or bushes.
Squatch blobs, they're called squatch blobs.
Yes, okay. Bigfoot in the UK, not the only Bigfoot in the UK. There have been other sightings, as there have been sightings all around the world. No evidence, apart from sightings from the occasional blurry photo, an occasional sloppy footprint in a soft soil. Apart from that, no dead big feet, no little Bigfoots, no family of Bigfoots, which you'd need a lot of families to actually keep going with a population. One Bigfoot does not a civilization make. They will die, and that'll be the last of the Bigfoot. So Bigfoot, male or female, they need mates of some sort, and they have kids, and you have to feed them, and it's unlikely that one sole Bigfoot is going to be the answer to everything. These pop up all the time. Someone was supposedly seeing a Bigfoot nest, which is a bit like gorillas, but they have a nest which is basically like a cradle. These Bigfoot nests are more like a little tent made out of twigs and things, so you can climb in and out. Let's find one. Let's find some real fur. Let's find a Bigfoot body, and then we'll be a lot closer to...
You want DNA, that's what you're saying.
You want DNA, and you want Bigfoot DNA, not deer DNA or bear DNA or koala DNA.
That's Tim Mendham from Australian Skeptics. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.